Hey, if you are new here, this is Chandan and you are watching the learning field. So in this video we are going to discuss about the questions of CSIR NET June 2021. This is the ODE section. Okay, so we are going to discuss the questions came in ODE of June 2020 June 2021 CSIR NET, which was held in Feb 2022. Okay, so let's start the video, and before starting the solution I am requesting you to all those who are new in my channel, please like the video, comment if you have any doubt in the comment section below, and don't forget to subscribe the channel. Okay, and already those who are new, I already solved the approximately 100 questions for PD for the practice of upcoming CSIR NET and GATE exam. So you can check, the links will be in the description and also here in the I tab. Okay, so for your practice you can check those videos also for PD. Okay, and also I'll solve some questions of ordinary differential equations also. Link will be provided in the description. You can check these videos also. Okay, so the question which comes in June 2022, the question 1, suppose if yx is a solution of the equation 4x y double dash plus 2y dash plus y, this is equal to 0, satisfying y0 equal to 1 and y double dash 0 is equal to, we have to find the value of y double dash 0. Okay, so this is clearly a homogeneous equation. Okay, you can solve this problem by using the series solution. Okay, but here we used a nice trick. Suppose since this is a homogeneous equation, we can seek the solution y equal to ax square plus bx plus c, suppose. Okay, since this is a second order differential equation, so we can seek the solution is of the form this. Okay, suppose this one. Now if we apply the given initial condition y0, this is equal to 1, this gives the value of c, this is equal to 1. Okay, this is easy to calculate this constant. We have to just calculate this constant. Okay, so if c equal to 1, then y equal to, suppose, ax square plus bx plus c. Okay, now with the find y dash and y double dash, so y dash, this is equal to 2ax plus b, and y double dash equal to 2a. Okay, now put these values. Okay, sorry, this is equal to plus 1. Put these values in the given equation 1. Suppose this is the given equation 1. We have what we have? We have 4x into y double dash. Y double dash means 2a plus 2y dash means 2ax plus b, plus y means ax square plus bx plus 1. This is equal to 0. So this is equal to, we can write ax square plus constant coefficient of x should be equal to 8a plus, this is 4a plus b into x plus the constant term is 2b plus 1. So this is equal to 0. Now equating the coefficient of like powers of x, we have first this 2b plus 1 constant term, this is equal to 0. This means b equal to minus half. Okay, now this is the coefficient of x is equal to, also equate to 0, you can equate to 0. So 12a plus b, this is equal to 0. Okay, and this implies a equal to minus of b by 12. Okay, and if we put the value of b, then this gives a equal to minus 1 by 12 into minus 1 by 2. This is equal to 1 by 24. Okay, now you can argue that the coefficient of x square should be equal to 0, and which gives a equal to 0. But here one thing is noticeable, that if the term x square equal to 0, the coefficient of x square, that is a, if we take a equal to 0, this never can be a solution of a second order differential equation. Okay, this thing can be noticeable. Okay, so we don't take a equal to 0, a not equal to 0, we consider here to get the solution in the form of this. Okay, so we get the value of what, a, b and c. Okay, so we put y equal to ax square, means 1 by 24 into x square plus bx, that means b is minus half. Okay, so minus 1 by 2 into x plus 1. Okay, this is a solution. This is a solution. This is not the proper solution or original solution. Okay, suppose we take a solution, we suppose a solution and calculate the coefficient. This can be a solution, or this is a solution you can take. Okay, so we have to find the value of y double dash 0. Okay, so y double dash means here this is equal to completely 2a. Okay, so y double dash this is equal to 2 into a, means 1 by 24. Okay, so this is constant term. Y double dash x, the value of y double dash x equal to 1 by 24 means 1 by 12, which is a constant. That means y double dash any value of x, this gives 1 by 2. So this is the easiest way to solve these questions. Okay, in the examination hall. Okay, so here option B is clearly correct. Okay, there are many other methods to solve this question. This is not only the only method. Okay, so there are many other methods, you can apply those methods also, but it is, I think this is the easiest method to solve this question. Okay, now go to the next question. Question number this is a question. The question says that consider the following initial value problem, that is dx dt, this is equal to x cube and x0 this is equal to 1, and the second one is this is a, and the second one b is dx dt, this is equal to x sine x square, where x0 is equal to 2. Okay, here two assertions are given. The solution of a blows up. What do you mean by blows up? In finite time. The meaning of blows up means the value, this is clearly a solution in x and t, or you can think about x dat or to x. Okay, so this is a graph with the axis x dat, that is velocity and this is space vector x. Okay, so what do you mean by a differential equation physically? Okay, so the physical meaning of a differential equation means the fluid flows. Okay, the fluid, just a minute, the fluid, fluid, fluid flow. Okay, so fluid flow, and here the solution to a is blows up, that means, and this is the velocity of the fluid with respect to the time, dx dt means. Okay, so we have to find blows up means the velocity of the fluid increase in a finite time. Okay, blows up means this. Okay, in a finite time. So देखो, this problem is not not to solve. Okay, you have to just say that whether the solution, we have to just analysis the solution. Okay, there is no need to solve this problem. Okay, so how we can find the solution? Okay, see, given that we have to just find the solution blows up in a finite time or not in the neighborhood of this. This is the initial condition which is very important role play here. Okay, since at the time t equal to 0, at the point t equal to 0, the value of x0 equal to 1, it is given, which is initial. Now if we plot the graph, suppose y equal to x cube graph, the first graph, the types of the graph is like this. Okay, so x cube graph means like this. Okay, and this is the graph with x dot versus x graph. Okay, this is x dot versus x graph. Now x0 equal to 1, this is clearly line. Okay, x0 equal to 1, so this is clearly, suppose this is the line x0 equal to 1 line. Okay, so this is suppose x0 equal to 1 line. Therefore the solution dx dt is in this neighborhood 0. Okay, the solution this is the graph is increasing clearly for all x greater than 0. Okay, since this is the x positive and x dot also positive. So x, for all x greater than 0, the graph of the function, this is increasing, okay, and this is the line x0 equal to 1, and in this neighborhood the graph is clearly increasing, okay. So increasing means, and this is a finite time, so in the neighborhood of the point x0, that means t equal to 0 point, suppose x0 equal to 1, this is the x0 and this is suppose 0 point, okay, so this is 0 point and this is x0 equal to 1 point. So in the neighborhood of this point x0 equal to 1 or 1 point, the solution, a curve of the solution dx dt, this is clearly increasing, okay. This is a special type of questions. This type of questions is never asked before, I think, in the CSIR net. So this is the answer. That means the option A, the solution A blows up with finite time. This is true statement, okay. So the option 1 is true. Now the second one is dx dt equal to x sine x square, okay. So dx dt is equal to x sine x square, okay. So the graph of the function x sine x square, this is like this, okay. Just see, and this is oscillates, okay. So like this, okay, and this is the like x sine x square. Suppose fx is equal to x sine x square, okay. The fixed point, suppose x star be a fixed point, okay, x star be a fixed point. This is the questions from stability analysis, okay. You can check for nonlinear dynamical system to solve this type of questions, okay. So this is, suppose x star be a fixed point, so if x star must be equal to 0, that means x star sine of x star square, this is equal to 0, that means x star equal to 0, and this is one fixed point and another fixed point is sine of x star square, this is equal to 0, that means x star square, this is equal to n pi, that means x star, this is equal to root under n pi, okay, root under n pi, and n belongs to suppose z plus because this is real solution, okay. If we take negative value of n, then this should be a complex number, but we have interested in here only the real solution, okay. So see, if x star belongs to n pi, that means x equal to 0, this is a fixed point, these are the fixed point for positive values of n pi, root under n pi, okay. So x star equal to n pi, that means this is suppose the point and x star equal to n pi means, suppose for n equal to 1, the value of x star equal to root under pi, okay. Root under pi means which is nearly equal to, since the value of this is equal to 3.14, so I think you can take the value 1, 2 means 2 to the 4, nearly equal to 1.5, 300 means 1.5 or 1.6, okay. So this is the point, suppose 1.6, okay. So and the initial condition is given that x0 equal to 2 point, okay. So this is x0 equal to 2, that means the 2 point is clearly like here, okay. So this is suppose 2 and 0 point, and this is the graph with x dot is to x graph, okay. So this is the 2 point, and in the neighborhood of the point this, the graph of the function, this is clearly decreasing, okay. You can check that this graph is decreasing in the neighborhood of the point, the initial condition x0 equal to 2, okay. Or you can check also, this is you can take also x is to t graph, okay. So this is the solution, x star x0 equal to 2, so this is the decreasing, okay. So we need to increase, in case of increase we say that the solution of the equation blows up, okay. But in case of the graph is decreasing, we can't say this is blows up, okay. This is not blows up case, you can say this is blow down case, okay. You can't say that this is blows up, because the graph is clearly decreasing in the neighborhood of 2, okay. So the case 2, the solution to B is blows up with finite time. This is clearly a false statement. Okay, so which option is true? Option B is clearly true here. Okay, this question is not to solve, you have to analyze the solution. Okay, so this is the solution. And one more question you can say that, sir, how can we draw the graph in the exam hall? Okay, so see here, if you not draw the graph, then you can also solve this question. Okay, so how can we solve this question? See, if x star and sine of n, suppose x sine n x square. Okay, this is the equation given, and the zeros are root under of n pi and 0. Okay, see, if you differentiate this term and check at the point n star pi, and one more thing, that this is suppose root under n pi, root under pi, and this is suppose root under 2 pi. Okay, so in between root under 2 pi, root under pi and root under 2 pi, you have just to check whether the graph of the function is increase or decrease in this interval. Okay, or you can break the interval also to check the case of maximum minima. You can easily solve this type of problems in case of maximum and minima. Okay, so you can solve in this way also. Okay, without drawing the graph. Okay, so this is the solution. I think this is you can understand these questions. Okay, if you understand, then please give a like to this video or like to this solution. Okay, and here is another question. Okay, this is also a question which is not generally asked in CSIR NET exam. Okay, so let f from R2 to R2 be a non-zero smooth vector field satisfying divergence of f is not equal to 0. Which of the following are necessarily true for the ODE x dot equal to fx? Okay, so there are the terms smooth vector fields. First, what do we mean by dvf not equal to 0? What is the physical meaning? The questions are not too directly solvable. Okay, physical meaning, you have to understand the question, the meaning of the question. Okay, physical meaning of divergence of f. First, what do we mean about the divergence of f? See, divergence of f means, so first divergence of f means the net rate of change of the mass of the fluid flowing from the, suppose the point x, y, z. This is 3 dimension. This is in generally we calculate the divergence in 3 dimension, and here question is 2 dimension. I just say the case or just want to say about divergence in the normal definition. Okay, so this is suppose 3 dimensionally fluid flow. Okay, so point per unit volume. Okay, per unit volume, per unit volume. This can be also thought as a tendency of a fluid to diverge from its point. That is, suppose this is a point, divergence of f means the fluid spread out from this point. Okay, the fluid spread out from this point, and with the rate of change of the mass of the fluid flowing from the point. Suppose this is the point P, X, Y, Z in an arbitrary point. Okay, in 3 dimensions. So this is the physical meaning of a divergence of f, that is of a field means of a fluid flow. Okay, so and one thing is smooth curve or smooth vector field. Okay, so what do we mean by smooth curve? So we know that simply if a curve is continuously differentiable on any r or r2 or r3, whatever it may be the dimension. Okay, so it is if it is continuously differentiable, that is if the function is not analytic at any point, then this type of curves is said to be smooth curve. Okay, the smooth vector field means the similar meaning of as smooth curve. Okay, so this is the meaning of smooth vector field. Okay, Now it is given that, and we have calculate how we calculate the divergence. So suppose f equal to in 3 dimension. So suppose f equal to f of x, y, z. Okay. So suppose f1 iota cap plus f2 j cap plus f3 k cap. Okay, in 3 dimension. So divergence of f, this is equal to d wave. That means what? We know that, just remind this, I del x plus j del y plus k del z. Okay, and dot of f1 I cap, this is vector, plus f2 j cap plus f3 k cap. Okay, so just this is a recalling. So this is equal to del f1 del x plus del f2 del y plus del f3 del z. Okay, this. Now d wave not equal to 0, it is given in the problem. What do we mean by d wave not equal to 0? See, for the equilibrium point, how we calculate the equilibrium point, how we find the fixed point. Okay, equilibrium point means we find the fixed point and we check the stability of the fixed point. If the fixed point is stable, then we say that the system or this is like that is in equilibrium condition. Okay, so for that case, to calculate equilibrium, we first find the fixed point. We equate f of x star, this is equal to 0, as we see in the above problem. Okay, if x dot equal to fx, that means for case of x dot equal to fx, if we equate fx equal to 0 and we find the fixed point x star, suppose. Okay, so this is the case. Now d wave equal to 0 means what? D wave in 3 dimension, d of f, this is non-zero. This means there is no fixed point. Clear? There is no fixed point. This is a case of vector field in 3 dimension or 2 dimension, and for 1 dimension, this is x dot equal to fx. We calculate just if fx not equal to 0, then how we calculate the fixed point? Okay, there is no fixed point if fx not equal to 0. Okay, in real case, or you can check whether any case. Okay, so if fx is not equal to 0, then there is no fixed point, and it is given that in R2. Okay, so R2 means we calculate just f, this is equal to f of xy, function of xy, this is equal to suppose f1 iota cap plus f2 j cap in 2 dimension. Okay, 2 dimensional vector field. So d wave non-zero means there is no fixed point, that is there is no equilibrium point. If there is no fixed point, then equilibrium point to next ki baat. Okay, so there is no fixed point. D wave not equal to 0 means clear. I think this concept is clear if you all guys. Okay, so देखो, there is no fixed point. Okay, so there is no fixed point, that means there are no fixed point. Option A is clearly true. See, there is another interesting thing. Okay, it is say that there is no fixed point. Suppose we take f xy. Okay, no fixed point means f xy never 0. Okay, so we think about the example. See, this is an example which is never 0. Okay, d wave is never 0 for any point of xy. You can check this, or this is easy, you know this. Okay, so this is never 0. Okay, for any values of x and y. Okay, so this is clearly a smooth vector field. Okay, so divergence of f means d wave. See, this is divergence of f means del x of this, that means exponential x, and del y of this means exponential this. This is never 0. Okay, so this is never 0, that means this is a smooth vector field. And see, if we take this example, then the remaining option are clear cut, we can say this. Okay, this is not a periodic function, that means there are no periodic solution. This is clearly option B true. Okay, and option C says that all the solutions are bounded. The functions, exponential functions, is never a bounded function. Okay, for any value of x and y. You can check whether it is for all r belongs to R2. You can't say that this is bounded. Okay, you can see, you can tell sir for g minus infinity 0, this is bounded. but this is not this interval. Okay, this is the R2 interval, and in R2 these functions are never bounded. Okay, and all the functions are unbounded. This is option D. Therefore option D, this is not bounded. Option D is clearly correct. Okay, this is my thinking this question. Okay, you can check, and whether if you there is any doubt, then comment me in the comment section below, because this is only my thinking. Okay, to solve this question, I think the questions and solve in this way. Okay, I think this is the correct method to solve this type of problems or these problems. Okay, you obviously comment me. Okay, because this is a very interesting problem. Next question, I first comes to this question. This is clearly based on Wronskian. Okay, the question says that consider the second order ODE x double dot plus px x dot plus qt into x, and let x1 x2 be two solution of the ODE in closed interval b, which of the following statements are true for the Wronskian W of x1 equal to x2. Okay, so Wronskian का जो independent Wronskian equal to 0 implies that x1 x2 are independent. No, this is clearly false, because we know that Wronskian equal to 0 means what? A linearly dependent solution. We get the linearly dependent solution, and Wronskian non-zero means linearly independent solution. This is if and only yes. Okay, so this is option A is clearly here false. The second option, Wronskian is change sign in the interval, but Wronskian never changes sign. Okay, since there are results, if x1 x2 are linearly independent, then they have never a common point of extrema, and since there are never common point of extrema, so in that case the Wronskian never changes its sign. Okay, you can say or think in this way also, and this is obviously a direct results also. The Wronskian never changes its sign in the any interval. Okay, so this is a false option, or in this interval, since x1 x2 are solution. Okay, and the third option says that if a Wronskian at any point t0 belongs to open interval ab equal to 0, then this implies this is 0. This is clearly correct from the result that if Wronskian at any point equal to 0, the Wronskian is either 0 throughout the interval or non-zero throughout the interval. If and any if at one point this is 0, that means this is 0 throughout the interval. Okay, this is throughout the interval, but Wronskian at the point, a specific point, this is the specific point t0 equal to 1 for some t0 belongs to ab. This implies Wronskian equal to 1 throughout the interval. This is never true. Okay, there are many values of this t0, many t0 for which you can find the Wronskian at that point is also equal to 1. This is never clearly not true option. So only C option is correct. This is clearly a easy problem. Okay, so this is another problem. Now it comes to the another problem. These questions. Okay, these questions is not solved thoroughly, but we discuss this problem. If any of you have any queries or any you can think about this question, then obviously comment me in the comment section below. If you are solvable, already solved this question, then you can comment me. Okay, so the perspective to solve this question is that let u be a positive eigenvalue eigenfunction with eigenvalue lambda for the boundary value problem u double dash plus 2 u dot plus at into u. This is equal to lambda into u. The boundary conditions are u0 equal to 0 equal to u dot 1. Okay, now we can write the problem as u double dot plus 2 u dot plus at minus lambda into u. This is equal to 0. This is, you can think, since the problem is based on eigenvalue and eigenfunction, so you can think this is a problem of what? Sturm-Liouville problem, SL problem. But I think there is a problem in this question. This is not exact form of Sturm-Liouville problem. Okay, the Sturm-Liouville standard Sturm-Liouville problem is like that: d dt of pt into dx dt. Suppose this is the variable plus qt into plus lambda rt into xt. This is a standard form of Sturm-Liouville problem, and where the function pt and pt qt rt are all continuous functions and rt must be greater than 0, and p dash t also, I think p dash t or pt must be greater than 0. But here if we compare this equation, standard Sturm-Liouville problem, then the value of rt equal to -1, which is negative. Okay, so this is the thinking of my point of view, and if you think so that this is a Sturm-Liouville problem, so you note that for Sturm-Liouville problem we are interested only in non-trivial solution. Okay, non-trivial solution, and in case of lambda equal to 0 we get trivial solution, so we are not interested on that. That means lambda equal to 0 is not a correct option. Okay, and similarly if you take lambda less than 0, you can see any Sturm-Liouville problem. If this problem is a Sturm-Liouville problem, I am not sure that this is a Sturm-Liouville problem, but this is similar to a Sturm-Liouville problem. I think there is some mistake, or I can't solve this problem. Okay, I just share my thoughts about this problem. Okay, so for lambda equal to 0 you also get trivial solution. Okay, so for lambda greater than 0 we get the non-trivial solution. You have open any books of differential equation and go to the chapter of Sturm-Liouville problem or boundary value problems. Okay, or boundary value problems, you find that you only get the non-trivial solution for lambda greater than 0 case. Okay, you can check in your book which you have read in graduation or post graduation for differential equation. So if this is a like Sturm-Liouville problem, or it is a Sturm-Liouville problem, then these two options we discard. Okay, so option A is clearly true since U is a positive eigenfunction. Okay, and I am not sure about the option C. I tried these options for the previous 2 days. That's why this video is comes late uploads. Okay, so I stuck on this problem only. I think that I'll solve these problems of CSIR NET 2021, but I only stuck in this problem. I can't solve the problems completely. Okay, so this is the option answer given in the answer sheet, but I don't know this type or these options. I approach many criteria to solve these problems, like Leibniz rule. I apply Leibniz rule for differential under integral sign, but I can't get any type of solutions or any option regarding this option C. So if any of you are solve this problem, then please comment me in the comment section below according to this problem, or if you have already solved this problem, then please comment me in the comment section below. Okay, so in this video these are the 5 questions, and these 5 questions are very important problems for CSIR NET. Okay, since this type of problems are new types of problem which are generally not asked in CSIR NET exams. Okay, so thank you friends, see you again in the next video. Thank you.